So I want to thank everybody for joining us this afternoon. We are talking about the regional costs of climate-related hazards for the New York State building sector. This is the third in a series of 6 webinars dedicated to talking about how climate change may impact the building stock in New York State. I won't go through this in great detail, just to say that as we are starting to understand the impact of climate change generally on New York State sectors, NYSERDA and other organizations in the state of New York have come together to try to understand some of the impacts on specific sectors like agriculture, et cetera. And so this research that is being presented today is really taking a look at what the potential impact of climate change has been specifically on the building stock of New York State. At the end of today's course, should be able to understand what climate hazards affect New York State buildings and its occupants, understand some of the vulnerabilities of New York State buildings through analysis of historical property damage, understand a little bit about the idea of adaptive capacity of each building sector in each region and how that may impact things like recovering from future events, and understand some of the knowledge gaps in our knowledge that must be bridged in order to prepare our building stock for climate change in the future. All 6 of these webinars have been generously supported by NYSERDA, who really supported all of the research that the University of Buffalo has been doing on this topic. And these webinars in particular have been supported by the USGBC New York Upstate chapter. This has been a lot of work by a team here at the University of Buffalo, so I want to thank in particular Lizzie Gilman, Hope Forgas, and TJ Mulligan, who all helped to pull this presentation together, and Hope is here today making sure that this webinar goes smoothly. If it doesn't go smoothly, though, it's not her fault, it's probably my fault. As we mentioned, and if you've participated in any of the earlier presentations, we have a number of different reports that have been pulled together on this topic. We've been working on this research actually since the summer of 2015, so we're happy to be able to share some of this stuff out. The report that we'll be talking about today is available on this website, ap.buffalo.edu/adaptingbuildings. At that site, you can find a lot more information more generally about how climate change is potentially going to impact the building sector of New York State, but you can find the report in particular that we will be talking about today, which is about the regional costs of climate-related hazards for the New York State building sector. Just a few items before we dive into the content of this presentation. So first, we ask that you please keep your mic or telephone on mute during the webinar to eliminate any background noise that you may have. And we ask that you please hold questions that you have to the end or use the WebEx chat feature to ask questions. And we'll try to get any questions asked in the chat as we go along. But at the end, you can either use the chat or just we'll unmute everybody and you can ask questions. And finally, this is the third, again, of 6 webinars in the series. The next session on climate adaptation strategies will be coming this Thursday at noon EDT. Please note that the webinar that we're doing starting this Thursday is actually a 2-part webinar, so it's going through this 25 different strategies over the course of 2 hours. So this Thursday and then the following Tuesday. Next week, the last session, next Thursday, we'll actually be going into energy modeling and talking a little bit more about how climate change is potentially going to impact things like energy use, but also passive survivability in New York State. So again, if you want to follow along and take a look at the report as we're talking about it today, ap.buffalo.edu/adaptingbuildings. So to start off the presentation today, last week, if you tuned in, we talked a little bit about the hazards that have impacted New York State. This presentation will start to put a little bit of the dollar amount to some of those different hazards that have impacted us over the last 50 years. With that said, to understand that total impact, it's important to understand what our building stock looks like across New York State. To do this, as part of the research, we actually looked into a lot of different data sources and actually settled on data from FEMA that is used for emergency management purposes and also for doing modeling of potential hazards in New York State, just to get a sense of what kind of buildings and where these buildings are located across the state. So if you look in total in New York State, a little over 90% of the buildings are residential buildings, and non-residential buildings actually comprise about 10% of the total building stock. In total, we have about 5.3 million buildings across New York State. The distribution of where these buildings are located, you can see, close to 40% of these buildings are in the 5 boroughs and on Long Island, but 60% of the building stock is actually in upstate New York, and so well represented in places like Western New York and the Great Lakes Plain, and also East Hudson and Mohawk River valleys, which includes the Capital District. As we take a look and try to understand how large our buildings are, so about 3/4 of the building stock in New York State is residential buildings, about 10.28 billion square feet. Non-residential buildings are about 1/4 of the total building stock, and as we look at it as a percentage, New York City and Long Island actually have about 7 billion square feet, or a little over half of the total building square footage around the state. In total, we're close to about 14 billion square feet of space in the state. And as we look what this building stock is valued at, in total, we have about $2.3 trillion worth of buildings in New York State. The majority of them are the residential buildings, our apartments, our homes, the single-family houses all across New York State. But certainly the non-residential building stock is a large portion of that. And again, in this case, the total value of the building stock, almost 2/3, or about 58% of the value of the building stock, is actually downstate in the 5 boroughs and in Long Island. You'll see also, as we have some of the larger cities like Albany and also Western New York, where you have Buffalo and Rochester, that you have close to around $300 to $350 billion worth of buildings in each of those locations. So although New York City may have a lot of the value of the building stock, there are other places that have significant cores of buildings. As we look where the buildings are distributed, it's probably not anybody's surprise to see that it actually follows the old path of the Erie Canal and now the New York State Thruway. So where we have the majority of our buildings is actually along that core. So going up from New York City and Long Island to Albany, and then over across Syracuse, Rochester, and Buffalo in the southern tier, represented by the largest city there in Binghamton. That's to say, when we look at the total number of buildings down in that location, we have over 2 million buildings that we're concerned about in the southern part of the state, and we actually have really significant density there. So in some places in New York City, we actually see something on the order in terms of total units, 16,000 per square mile. And again, as we go across the rest of New York State, right, and we move up from Albany across, almost 40% of the building stock is located in places surrounding Albany and Buffalo and Rochester. So certainly as we're trying to think about things like statewide policy or ways that we want to engage and reduce the impact of building climate change on the building stock, we need to look at those locations as well. As you look at what types of buildings are represented across New York State, the majority of buildings, again, almost 90% little over 90% of the building stock is actually residential buildings. A large percentage of those are single-family residential buildings. So as you look across the entirety of New York State, you can see outside of the urban cores of places like Buffalo, Rochester, Syracuse, right, and New York City, right, the majority of those buildings and the places where we live really are those single-family residential buildings. And so any kinds of policies that we begin to take on and trying to understand how the building stock is going to be impacted certainly has to take some of these buildings, this building type into account. And that's challenging because, as you can see, they're really distributed all across the entire state of New York. On the flip side, if you start to look at some of the commercial building stock, although only about 16% of the building stock in New York State is commercial, it also does start to be concentrated in the cores of some of the major cities. We're certainly concerned and want to find strategies that work for these buildings because that really is where our GDP is developed from, and also where our businesses and kind of the mission critical functions of our different businesses or institutions are located. Industrial buildings, just an interesting geographic kind of footnote on this. You can actually see the distribution of these industrial buildings along the I-90 corridor, along the old Erie Canal corridor. And so as you get into some of the cities that still have industrial functions across upstate New York, certainly is an important thing to keep in mind, how we have those buildings continue to adapt. And certainly a large part of New York State, especially upstate New York, right, is agricultural function. So in a lot of places that are more rural locations, you'll see a large percentage of the building stock is actually agricultural buildings. So there's really not something that we can leave out, even though on a building by building basis, certainly they may be a little bit less expensive than the total value that we see in some of the urban locations. So diving into looking at the density across New York State, again, I think it's nobody's surprise that downstate New York, really, and New York City, Long Island, have the highest concentration of buildings, and that most of the rest of the buildings are actually concentrated in a couple of different urban centers. But I think, and hopefully everybody can appreciate challenge, that really when we're talking about climate change and how it impacts the building stock, we can't just focus on New York City by itself. It really is something that we have to look at really all of these different types across the entire state, because they're important generators of our economy and certainly for our prosperity as a state of New York. So I want to make a little bit of a transition here to start talking about climate-related hazards and to get into a little bit of detail about some of the things that we actually looked at as part of this report. So if you joined us last week when we had our primer course and then talked in more detail about hazards, probably not surprised to hear that hurricanes are definitely a major thing that has impacted New York State. We're concerned about hurricanes and tropical storms because as you have a rise in ocean and atmospheric temperatures, we may see stronger hurricanes and tropical storms in the future. With things like sea level rise, certainly the coastal flooding and storm surge that's associated with these storms is expected to increase. As we look at flooding is really often the result of extreme downpours or precipitation events. We talked a little bit last Thursday about how these are expected to increase across the state by 2080, and some of the greatest precipitation events are expected to be seen in places like the Southern Tier, New York and Long Island, and also in the Adirondacks. Severe storms, so these are really the springtime and summer storms. As we have warming temperatures across the state, we're expecting to see the frequency and intensity of some of these storms. It may increase. Some research also says that this may increase things like wildfire, building fires, or other types of damage. And finally, winter storms. So for us in Buffalo and Western New York, this is an area where we really feel like we are beginning to understand this, but winter storms are something that counterintuitively may actually increase in the future as we see a decline in ice on the Great Lakes, causing more lake effect storms. Although some of those seasonal projections are a little less certain than the annual results, certainly the models suggest that we, by mid-century, may have really significant lake effect snows and then slowly transition into a different type of regime where below freezing events become less common. And I would say if you're interested in getting into the details of any of these hazards and actually a couple more in greater detail, we'll have the different webinars posted online hopefully a little later this week, so you can go back to review some of that information. So for this research and what we're presenting today, we wanted to take a look at and understand what the total statewide estimated damage has been to the building stock from these different types of hazards. And again, since all of these things are expected to increase in the future, we wanted to try to dive into a little bit more detail with the idea that understanding what's happened in the past may be a good precedent for what we may start to see in the future. So to do this, we really dove into data from 1960 to 2014 to assess the inherent vulnerability of the building stock. And I think it's nobody's surprise, hurricanes were by far the most costly event that hit the state, although they were the rarest events to hit the state, accounting for about 42% of the total damage over that 55-year period. So Hurricane Sandy, just in itself, if you look at the orange, was about $10.5 billion worth of damage to New York State buildings. And then Hurricanes Floyd and Irene came in at about $250 million, $240 million. In total, though, the damage we've seen around New York State has been about $25.7 billion since 1960. Again, the majority of that was from Hurricane Sandy, but as we look at some of the other things that have certainly caused significant damage, flooding comes in around 28%, severe storms at about 17%, and winter storms at about 12%. I would say there was a significant challenge in finding some of this data and beginning to parse it out to the different locations. We won't go into the greater detail about that today, but there's always a certain amount of error associated with any of these types of estimates. As we look where the damage has been around New York State, it certainly has not been evenly distributed. So again, with Hurricane Sandy as a $10.75 billion event, it really was focused on New York City and Long Island. Although if you look at the slides, you'll see that for each of the other regions, especially the ones downstate, so the Hudson River Valley, there is damage associated with the hurricanes actually coming up the coast, coming up the river valley, and doing damage from flooding and other kinds of wind-related damage. But again, hurricanes in this case were the largest impact on the total building stock. We certainly because the New York City is a place that can be quite vulnerable to these types of events in the future, is something that we need to begin to develop strategies to begin to address this. When we look at this, though, and actually dive in to look at the damage as a percentage of the total building stock. So if you think about the total value of the building stock in a given location, one of the surprising things that came out of the research is that damage that happened in New York City as part of Hurricane Sandy and other hurricanes was actually only about 0.8% of the total building stock value. And for events other than hurricanes, it was 0.4%. So what this means is, yes, we need to focus on hurricanes, but as we start to look at the damage that has actually happened in some of the other regions, like in the southern tier, places like Binghamton, all right, we've actually seen a much higher percent on the order of 3.3% damage as a percentage of the total building stock assessed value. What that means is, although the majority of our buildings are in New York City, we can't ignore upstate. 60% of the buildings still are located upstate. And as we think about strategies and we think about ways to begin to respond to some of these different hazards, places like the Catskills, which have a lower density, places like the southern tier, places like the Adirondacks can actually be far more affected by smaller storms when you take a look at it in terms of the total value of that building stock. When we also put this into terms of the damage per capita, you can see similar things emerging. So again, although Hurricane Sandy was on the order of $10.75 billion, when we look at that on a per capita basis, down in the 5 boroughs in Long Island, it comes out to around $1,000 worth of damage over that 55-year period. When we look at the damage per capita in some of the more rural locations, right, we're looking on the order of $3,500 in places like the Catskill Mountains in the southern tier, or right around $3,000 in the Adirondack Mountains. And again, because these per capita estimates are actually higher, right, than in places like New York City, or certainly in Western New York and the Great Lakes Plain, right, that can actually be something that's more challenging for some of these rural locations to actually bounce back from one of these events or to prepare for some of these events in the future. And we'll get into that in a little bit more detail shortly. So some of the key findings from our analysis of the historical cost data. So again, just to say it one more time, hurricanes have certainly been the most destructive, although the rarest events that we've seen in New York State. When we look at these events, they are something that impact more than just New York City and Long Island, right? This is something that can move up the Hudson River Valley, certainly move up into the Adirondacks, cause damage from high winds or cause damage from other types of flooding. However, as we start to look at other locations across New York State, before Hurricane Sandy, flooding events were the most widespread, frequent, and costly events in New York State. They actually were the only events that have impacted all 62 counties of New York State. So as we're planning and we're thinking about how we begin to respond, how we begin to prepare the building stock, not only are we thinking about hurricanes, but we're also thinking about, how flooding may begin to impact these things. New York City and Long Island certainly sustained the most building damage in terms of single cost, but they did not sustain the most damage per total building value or per capita. So as we think about ways that we want to begin to adapt, how do we begin to drive work, into the more rural locations and make sure that those locations are also prepared for these events? Certainly with the existing building stock, that's probably one of the biggest challenges that we're going to face in the near and midterm. Winter storms are not widespread events, but they can cause significant damage in the western New York and Great Lakes Plain region. Certainly in seeing things like a Snowvember event that happened here in 2014 in Buffalo, although buildings generally are designed to respond to snow events, they may not be prepared for things like these really significant lake effect snows, and so you can start to see roof collapses as part of that. Certainly when you have wind-driven snow, it can actually begin to cause damage that way as roofs are loaded unevenly. But a lot of the damage also comes from icing and other types of ancillary impacts with these storms, or trees falling on buildings, etc. As I've said, some of the decentralized regions, some of the more rural locations may be more impacted by climate change than other regions of the state, and I'm going to unpack some of that a little bit more here in some of the next slides. And if you're looking for a place to relocate, the Tug Hill Plateau region has had the lowest exposure to climate hazards. There's been a lot of interest recently in like a New York Times article about where is the best place to move in the face of climate change. Although I don't want to endorse any one particular location, it is notable to say that Tug Hill Plateau, while it gets a really significant amount of snow, has actually had some of the lowest damage to the building stock in the data that we looked at. So making a little bit of a transition away from the costs on a statewide basis, I now want to actually go through and look at some of the different regions of New York State. The regions that we're going to be walking through are actually based on the ClimAID regions. So these are 7 different regions that are actually defined as different climate zones within the state. It's notable to say that they don't actually line up with some of the ways that other analyses look at it, so that's not necessarily like from the same kind of economic analysis regions that different state agencies would use. This is really kind of pairing together different regions from a climatic standpoint. And this is something, if you go to the ClimAID reports on NYSERDA's website, you'll see that this is the unit of analysis for all of those reports. So the first region to talk about, not because we're from Buffalo, but because this was actually listed as Region 1, is the Western New York and Great Lakes Plain. So in Western New York, we really haven't seen any property damage recorded between 1960 and 2014 for hurricanes. But as we look down through flooding, we've seen about $82 million, $0.86 million. We've seen about $0.29 million or $290,000 in terms of severe storms. In the winter storms, we've actually only seen about $1.5 million. And this is the regional cost, the average cost per event that we've had. In total, as we look, really the majority of things that we have are severe storms in Western New York and the Great Lakes Plain. I know certainly a couple of weeks ago we had really significant windstorms that caused a lot of power outages, and people had a lot of flooding damage actually in their basements because things like sump pumps were shut off with the power outages. The total costs, though, although we've had a lot of severe storm events, the winter storms are really something that have caused the most amount of damage, on the order of $780 million. And then we look, again, the severe storms are a little bit less, and the flooding is third on that list. As we move to Region 2, which is the Catskill Mountains. So in the Catskill Mountains, severe storms have also caused really the most amount of damage, followed by flooding. It's actually almost a 40-40 split, about $1.7 billion for both severe storms and flooding. Hurricanes, though, as they come off of the Atlantic, and winter storms have also done quite a bit of damage in these locations. And so certainly as you're thinking about, if you're working on projects in that region, these may be some of the different hazards that you want to begin to prepare for. And certainly this is something that the insurance industry is concerned about and thinking about going forward. Region 3 in the southern tier. I think one of the really important things that stands out when you look at the southern tier and you think about the Susquehanna River Valley is the flooding associated with that river valley as the water moves towards the Chesapeake Bay. Flooding has been on the order of $2.2 billion. So before Hurricane Sandy, really that flooding that we've seen in those locations was the most significant, some of the most significant hazards in New York State. Although we've had a lot of severe storms on the order of 1,700 events in that time period, you really can see that the majority of the damage to the building stock has actually come out of those flooding events. And certainly a lot of money is now being invested in preparing places to respond to flooding in the future. Hurricanes, a very small amount of the total damage in the southern tier. A lot of that is associated with the remnants of storms coming off the coast. And we're going to talk a little bit more about this as it relates to adaptive capacity, because places like the southern tier having really significant flooding events may actually have less construction industry to actually support preparing for this in the future, less ability to adapt to this in the future, and something that we may want to begin to address in policy. Region 4, New York City and Long Island. We've talked a lot about Hurricane Sandy, so you can see that in the donut on the right that it really kind of overwhelms all of the other damage that we've seen in those locations. Really just the Hurricane Sandy alone has caused the majority of that damage. That's not to say that we can ignore things like flooding and severe storms or even winter storms, but on a percentage basis, it certainly has been a lot less damage to the total building stock down there. On the flip side, though, these types of events, things like Hurricane Sandy, it's only been 3 events that we've seen from 1960 to 2014. So preparing for those major events is important, but preparing also for the everyday events, the severe storms, is something that we also have to keep in mind. And the damage, really, again, is because the highest concentration of buildings and population are down there, but the total per capita building stock is lower than some of the other locations we looked at. Region 5, which is the East Hudson and Mohawk River valleys. So this is really the entire eastern portion of the Hudson River going all the way up into Schenectady and up into more rural locations like into Jefferson County. So as we look in these types of locations, flooding really does tend to predominate. So on the order of $2 billion worth of flooding has been caused. Again, this is something that's really notable because outside of Albany, Schenectady, and Troy, these really do tend to be some more rural locations within the state. And so it's causing a lot more damage on a per building, on a per capita basis than we're seeing in some of the other locations in the event. Certainly hurricanes have been something that have been important as they come up the coast. Things like Floyd and Ike, in addition to Hurricane Sandy, are certainly of concern. And as we talk about flooding, and as we think about things like sea level rise in the future, this type of flooding is something that goes all the way from the Atlantic Ocean up to Troy Dam, up into Albany itself. Region 6, the Tug Hill Plateau, really is one of the places that's had no damage associated with hurricanes during this time period. A lot of the damage has come from severe storms coming off of Lake Ontario and certainly the winter storms. But as we look at this as a percentage of the total damage in New York State, this region has actually seen the least amount of damage recorded as a region. And again, some of that has to do with how the regions are defined. So before you decide to, move to Watertown, you may want to parse out some of this information on a little bit more of a county by county basis. Finally, Region 7, which is the Adirondack Mountains. This has really seen a little bit of everything. So again, the hurricanes coming up from the coast have actually done a fair amount of damage on the order of $9 million, which is significant because of the low density in some of those locations. The majority of impact has been, although severe storms are the highest number of events, the flooding, associated with those events on the order of $500 million has really been one of the big drivers. And certainly winter storms, I believe that the Adirondacks are right after the Western New York, Tug Hill kind of areas in terms of the total damage from the winter storms. So thinking about how we begin to adapt in some of these more rural locations, I think is a really critical issue going forward. So we went through some of the impacts to some of the different regions. I want to dive into a little bit more detail to talk about an issue that's important and an important issue to think about as we get into some of the adaptation strategies that we'll be talking on Thursday for next week. So the idea and the thing that we want to talk about is this idea of adaptive capacity. And so adaptive capacity is something that is defined as the ability of a system to adjust to actual or expected climate stresses or to cope with the consequences. So as we look back at some of this historic data, right, as we look back and see where the majority of the building damage has happened across the regions of New York State, we can begin to use this to expect what some of the climate stresses may be in the future. And what's important is if we understand how we have coped in the past, we can begin to design policies and strategies to adapt or to cope with these things in the future. Some of the actions that we use to build adaptive capacity really aim to lessen the total physical, social, and economic impacts of climate change. And it's important that we bring out and talk about the physical, the social, and economic, because while we talked a lot about in this report some of the economic impacts of climate change, and some of the earlier things talked about some of the climate hazards that can do physical damage to buildings, and certainly we try to quantify some of the physical damage in here, this certainly can cause great stresses on some of our social systems, and that's not something we want to lose sight of, because oftentimes in some of these rural locations with perhaps less income or lower densities, or certainly in our cities where we have lower income or minority populations, may have less capacity to adapt. So we may want to actually think about in our policies and work how we drive resources to those locations to make those locations less vulnerable to climate change or more resilient to climate change, if we want to use the R word. And building that adaptive capacity is really something we have to think about, taking advantage of new opportunities that may emerge from a changing climate. So we'll be talking about a little bit in about a week and a half. There are some things like having a reduction in total heating usage as the climate begins to warm is potentially a positive thing, potentially less greenhouse gases associated with that. That may be something that we begin to think about incorporating into building design. But on the flip side, there may be unintended issues that go along with that warming climate, like having increased cooling loads or other kinds of things that can do a lot of damage to the building stock. So it's not just vulnerabilities, there are also some opportunities, and we want to be on the lookout for both the vulnerabilities and the opportunities as we plan. So as we dive in and as we looked at some of this data as part of this research, right, we wanted to see what the capacity was of the New York State construction and design sectors to begin to respond to some of these issues. And so we broke out for each of the 7 different regions of New York State, the total building square footage, but then we also wanted to look at the total employment in the construction industry in the AEC field. As you go down through the different regions, you certainly can see Where we have greater concentrations of cities, so like in Region 1, where you have Buffalo and Rochester, there are a fair number of organizations actually dealing with the construction industry. And certainly as you move to a place like New York City, where you have almost 24,000 firms and almost 200,000 employees, there's a very robust sector to begin to think about. These folks are the ones who will begin to help adapt the building stock or respond to any of these different types of events. I'm not going to go through each one of the regions, break them out like we did with some of the costs, but I do want to point out and talk about two different regions side by side. So the two regions that we want to look at side by side are Region 3, which is the southern tier, places like Binghamton in the Susquehanna River Valley, and Region 4, because this is really an exercise in contrast. It really lets us understand a lot about what's going to happen as it relates to adaptive capacity and adapting the building stock. So as we look at the total square foot per construction employee and firm, this is really defined as the amount of building space that each firm or employee would be responsible for. If you think about this as a metric on average in the region. So the lower the figure, right, the higher the adaptive capacity, meaning if you have less building stock that you actually have to manage, right, it's going to be easier for you to manage that or to make the repairs or changes to it to begin to adapt to some of these changes in the future. Again, as we look at the southern tier, Region 3 versus New York City and Long Island, you can see that in the southern tier, each one of those the total square footage per firm, right, is almost double in the southern tier than it is for New York City. And as you look at per employee, right, really meaning that we have fewer people there in the southern tier in that region to begin to adapt the buildings. If we want to respond to an event, it may mean that we're bringing in additional people from outside the region to help deal with this kind of issue. And this ends up being really important as we think about how we spend, right? And how after a disaster, money potentially can be infused into a local economy to begin to respond. And so the idea here, there's three different ways that money, when you have direct spending, comes into a regional economy. There's first a direct effect, which is really how that money directly comes in to either adapt to an event or to begin to put money into adapting buildings for the future. So this might be something like a payment to a contractor or design professional for building retrofits, for new buildings, or some kind of post-disaster recovery activity. When you see economic activity reported out, this is really the easiest way to understand that. But when that money comes into the economy, you also have indirect effects and induced effects. So an indirect effect is really additional activity caused by direct spending as they perform their work. So if they buy materials, if they buy other kinds of commodities from subcontractors, that money begins to bounce around the economy. They may be buying steel, for instance, from local manufacturers, or if the steel actually comes from outside of that economy, that money is then actually leaving that particular region. In addition, there are induced effects. And so an induced effect is something like an employee of the businesses take their wages and they actually use that to create even more economic activity. So if you imagine a contractor receives money to respond to flooding that has happened in a location, to begin to repair buildings, they get a payment potentially from FEMA. That's the direct impact. As they begin to buy materials to respond to things, that's the indirect effect. But then when the contractor gets their paycheck and they go and buy a cup of coffee, right, that money continues to bounce around the economy. So when we think about what this means and we think about how we want to build adaptive capacity, it's not just about actually thinking about how much money or how much square footage we put into those particular locations. What becomes really important is we also have to think about how that money begins to bounce around the economy. And so in some of the places you can see here, these are different multipliers for the building stock. So the red is non-residential buildings, the blue is residential. What this means is that if you put $1 into the economy, it bounces around an additional times to get 50 in the case of at the top. About 53 to 54 cents of spin-off activity as it's moving around the local economy. And so places that have a higher number, like New York City or like a place like like Western New York, means that money stays in the economy much longer. And so it's really important to keep this in mind as we think about how we want to begin to adapt, because it's not just, again, about the strategies for the buildings, but it's also the strategies for building a workforce and making sure that money stays in the economies to continue to help other businesses adapt to some of these issues. So again, as we look and just compare two regions, Region 3 of the Southern Tier, right, there's much less of that indirect and induced effect in a place like the Southern Tier, because the money leaves the economy either to bring in materials as part of the indirect effect, or the induced effect is smaller because it's more distributed, has a lower density than a place like New York City and Long Island. And we would expect, actually, when we looked in the data, the number in the economic region of what we would consider New York City and Long Island, looking at places like New Jersey, for instance, the number's a little bit lower than one might anticipate, simply because there are so many suppliers that are just across state lines or just across in other locations. So, there's some really significant challenges as we're moving forward. We spent probably about 18 months on this research. Paul Ray, who is listed at the bottom, really led the effort here at the University of Buffalo. And again, the different reports in this report are available on our website. There were some definite limitations in terms of how we dove into this data. One of the biggest things as we tried to pull this information together was just understanding site-level data on building attributes. And we went to a lot of different resources to try to find out how buildings were constructed or what the damage from different events were on sites. We really didn't find any statewide resources and actually had to rely on some of the federal data. And I would say that ended up being a real limitation. And so we hope to see in the future, more of these resources developed with more detailed information so that we can begin to do this type of research. One of the other big things that we ran into was finding historical loss data. So from these different types of events can be quite challenging, and not having this data certainly can be an impediment to beginning to adapt in the future. So when we went through, we settled on a certain database from the University of South Carolina, which is considered to be a fairly clean source, but there's always uncertainty in these types of data, and really what we wanted and hoped to find was the insurance data that would actually respond out from individual events. Unfortunately, the insurance industry, that's their secret sauce. They don't want to share that information outside of their actuaries because that really is how they develop their own models. But hopefully in the future, we can find ways to collaborate with these types of organizations, so that we can develop effective adaptation strategies. And certainly that would be not only to the benefit of statewide policy, local planning, but also for the insurance industries that are concerned about climate change. Finally, one of the challenges that we found in doing this research was just getting data and understanding what some of the potential impacts might be in the future. We chose to look at the last from 1960 to 2014 to understand what those hazards have been, but looking into the future and seeing what some of those predictions might be. There's still a fair amount of uncertainty about some of these topics, and so what we looked at as a historical precedent may not be perfect for the future, but it was really our best way to do this, we felt, for the research. And then certainly as you get into the data on loss estimation, there are a lot of challenges around accuracy of that data. So when you see the numbers reported on the news that a storm caused $100 million worth of damage, oftentimes that's the National Weather Service going out and just estimating based on what they see, what they think the damage has been in a location. That really can vary location to location around the state as you have different offices. So making sure and going back through that data to normalize it is something that's very challenging to get an accurate result. Going forward, we really do hope, and if anybody's from the insurance industry on the call, that we would love to work with them to find ways to share some of the data to make it more open source so that we can begin to develop effective statewide policy. Again, this would be something of benefit to the AEC industry, but also a benefit to statewide policy, local planning in the insurance industry. The challenge always is, that's something that really is someone's business model. So doing that in an effective way is hard. Comparing among the different locations, I mentioned earlier that the different regions are something that's slightly different from how the state measures economic impact. And so we chose to stay with the ClimAID data as part of this research, but knowing that it doesn't perfectly align, getting the different state agencies to work among each other and figuring out how this might align with economic impact is certainly one of the important next steps and would help some of the things like climate smart communities planning. And finally, really the lack of local level loss estimations, really being able to get into the nitty-gritty detail was something that we had hoped to do as part of this research. But again, after working on this and with this team for almost 2 years, we found that just a lot of that local data is either not in any location where we can pull it together and make it comparable, or it just doesn't exist at all. And if we want to have those policies in the future to help our building stock begin to adapt, we need to figure out ways to perhaps get county governments to work together. So that was an overview of some of the regional costs of the different climate-related hazards in New York State. Again, we want to thank NYSERDA for supporting this work over the last several years and really being a great partner in terms of making this research happen. We also want to thank the U.S. Green Building Council, New York Upstate Chapter. Don't want to fail to mention again Lizzie Gilman, Hope Forius, and TJ Mulligan for helping to pull together not only some of these reports, but also specifically these presentations today. And I'll just make one last shameless plug for our website and say that if you want to find this information, if you want to go into more detail into this report, it's about a 60-page report. Summarizing it up in 50 minutes is quite a bit of a challenge. Please go to our website, ap.buffalo.edu/adapting-buildings. Take a look, download the report for free. If you have any questions about it, we're certainly happy to answer your questions. And my contact information is ap.buffalo.edu/Rajkovich. So after this webinar is over, based on your attendance, we'll be sending this stuff to Tracy Hall at the USGBC to earn you the AIA credits. There are no quizzes associated with this. And if you found the last 3 webinars to be of interest, or you're just frankly joining us today, I'll say that we're starting a 2-part series this Thursday on climate resilient strategies. And so we'll be getting into a little bit more detail about how we can actually begin to adapt the building stock. So again, that'll be this Thursday at noon. You can register through this website. So I will just end the presentation there. And I will try to unmute folks and just ask if you're not, I'm going to unmute everybody here, but if you're not planning to ask a question, perhaps just keep your phone on mute. So have unmuted everybody, and if you have a question, you can ask it now or just type it into the chat feature. So does anybody have any questions?
Hello, can you hear me?
Yes.
Oh, great. So I know that there's rebates and incentives for energy efficiency products out there, and of course renewable products as well. It's very difficult to evaluate the measures that are related to resiliency, there's certainly a sustainability component to many of them, like insulation. But I'm wondering if there's a way to evaluate these a little bit better, or if that's being worked on. If you could just speak to that.
Sure, that's a great question. So to maybe rephrase the question is just that it's quite difficult to value something when you perhaps don't know what the risk is going to be in the future. So does it make sense to begin to invest in a building now when you don't know, let's say, how many hurricanes there might be in the future? That's something that FEMA actually has a cost estimating tool which can help you with starting to do some of that cost estimating. We were hoping as part of this research to actually do some detailed cost estimating, but when we looked at that on a region by region basis and a building type by building type basis, it was actually something that was entirely a new research project all unto itself. I would say something like that probably would be very helpful in the future to have some of those case examples. And I know that the National Institute of Building Sciences has just released a report where they estimate that making those investments actually has a $6 return for every dollar invested. But it's still something I would say I would agree with you is a little bit harder to quantify than something like an energy efficiency measure. But hopefully as we get a little bit more sophisticated with this and start understanding some of the risks, that data will begin to follow. Well, if there aren't any other questions, I'll let people go. They can enjoy their last couple minutes of lunchtime. I'll stay on the phone here if anybody has an individual question, but thanks very much for participating today, and we hope to have you join us this Thursday when we start to talk about climate strategies in a two-part seminar.